Water scarcity and waste overload are two major crises faced by the world today. The question is, can coal ash waste be a game changer for circular economy? Coal combustion in thermal power plants produces two major byproducts, coal fly ash and coal bottom ash. Their disposal is a major issue as they severely contaminate groundwater and water bodies. But this waste material is a storehouse of expensive ceramic materials such as alumina, zirconia, titania. Turning the waste into ceramic membranes using 3D printing technology to fabricate non-patterned and patterned self-supported membranes solves the problem of environmental burden caused by its disposal and also minimizes the cost of the raw material. The wettability of the membrane surface evaluated by contact angle measurement is a deciding factor in water treatment applications. On tuning the wettability, our coal ash membranes demonstrated superhydrophilic nature to superhydrophobic nature, thereby making it suitable for broad range of application from ultrafiltration to pervaporation separation. Isopropyl alcohol is an essential chemical extensively used in the semiconductor industry. The problem is this pollutant forms azeotrope mixture in water, which makes it difficult to separate when discharged in wastewater. Our highly compact hydrophobic zeolite membrane derived from coal ash successfully separates the IPA water mixture via pervaporation, thus replacing the high-cost conventional polymeric membrane and also reducing the energy consumption of the entire process. So coal ash can be a game changer towards the circular economy. It can turn dirty water into clean water. Naphthalene is the membrane of choice for proton exchange in microbial fuel cells, but it costs a whopping sum of $1,700 per square meter, which makes the large-scale application of microbial fuel cells difficult. Our ceramic membrane recovered from coal ash successfully replaces naphthalene as a low-cost alternative for simultaneous wastewater treatment and electricity generation through microbial fuel cells.